Hello everyone, my name is Hayati and I'm an application engineer at RapidScan 3D. Today we're going to go over how to reverse engineer this rim. So first I brought it into Design X and create my regions, and as you notice there are some areas that it's not scanned fully, which is okay. This is how we're going to figure out. The next thing I'm going to do is I'm going to create my regions, and then we're going to create the plane. But first of all, we're going to create the axes because we're going to rotate that plane at that axis so we can capture the most geometry. Now, notice selecting these two axes and then the plane. Once I'm done, I can, from top view, and rotate my plane, because that feature right there, it has the most features being captured by a scanner. So after that, I'm going to accept that. Now we're going to go to Sketch, Mesh Sketch, and we don't need to move our plane. We're just going to hide our model, and then we're going to start sketching. I'm going to do a section cut here so I can see better. There are some features that Mesh Sketch did not capture. Once we're done, I'm going to zoom in, and we're going to select the auto sketch. And auto sketch is really useful. You don't need to click every single line. As you notice, there are some areas that it's not really clean. What I'm going to do, I'm going to go to trim them. And then put fillets and adjust it. Most of the time rims are heavily used on the road. They bent. There's some inconsistency in some areas, which is normal. And I'm going to create the rest of this stuff. I'm putting these arbitrarily because I'm going to cut those after. Auto sketch this area, and then put some, I'm going to lock that in place, and then connect that there, and we're good. Our goal is basically capture as much as geometry in that area. There are other ways that we can get rid of some of the cuts and extrudes and fillets. So we're just basically adjusting it. If you notice, that area is cut out, and I basically capture the external, not just internal areas. If you're a SolidWorks guy, pretty easy to use this software. There are very similar trim and create lines. And if you notice, there's an option there. I turn on my disconnecting edges command, and the ends are always turning green and tells you if you're missing anything. The next step is, after I'm completing my geometry sketch, I'm going to revolve it. I select my axes, and it's done. And we can turn on our analysis. We can see 90%, it's pretty good. Warpages, that's pretty normal. You can't always get 100% because there are wear and tear in these parts. And add some fillets here and there. And estimate again. That looks pretty good. Now we have a few more features we're going to be creating. This is one of my favorite section. Once we're done with fillets, we're going to go to the 3D sketch, 3D mesh sketch command, and we're going to select spline. So what I'm doing is basically connecting each spline on top of the mesh data. This is very, very important. You have to make sure that you follow the edges really nice and clean. I usually follow the end of regions. If you notice, there are different colors. You want to try to organize it, all of them, all these nodes, nice and clean. Each node is important. You can go back and edit them. You can move them. You can adjust it. And if you go over that curve, it actually replicates it, so it won't spill. And once you finish, you see the ends are connected now. What I'm going to do, these are the spline nodes, and then I'm just basically organizing them. Once that's done, I'm going to continue creating another one right underneath. Follow the path very easily. Follow each corner, each curve. So what I'm going to do, I'm going to pull it down and connect it to it, and then adjust these. And there's an option here, merge. Both of them merged already. Sorry about that. As I mentioned earlier, you gotta have to play with the geometry. Pull it down, pull these nods really smoothly so you don't spill over. Zoom in, pull that down. You can select the whole spline curve and then just move it down if you needed to. Once it's done, I think we're pretty much got them all. I'm just waiting for the process it. I'm going to modify it a little bit more. Once I'm done, I'm going to go add in legacy boundary fit. It takes a couple seconds. I'm doing the same time I'm explaining, so forgive me. And select that curve, and then that was already selected. Yep. And here we are. What the software is doing is calculating the surface area and creating you a patch that fits in whatever is inside of those two curves. So once that's done, I'm going to hide my model so you can see it. Once it's completed, it perfectly gives me the internal shape of it. The next thing what I did is I extend the edges. Once I extend the edges, it creates the surface. And I use that surface to cut the inside of the pocket. And here I am. And the next thing I created a circular pattern from the axes, and then once it's done, we got the rim. Tool entities 1, 2, 3, 4, 5, and then body. I'm going to bring my model back, select the rim, and click on the remaining body, and we have the rim completed. All we need to do is put some fillets and then create the bolt holes. And then transfer over to SolidWorks. What I'm going to do, I'm going to select these surfaces. We have an option here, wizard, and I'm going to use a revolution wizard. And selecting surfaces, and I created the bodies. And then once I'm done, if you notice that they're a little bit shorter, so I'm going to go back and edit my sketch. Pull that line a little bit higher. Perfect. Now I'm going to go back to circular pattern again, select my axes, select all the models, and then basically a Boolean command, and we are completed. The last thing left is taking all my data, transfer over to SolidWorks, and then finish or modify the areas that it requires, or send it to a machine shop for CNCing. The light bulb kind of thing on the right side, distance, it's a wand. It's actually select the surface that you want to fill it and then click on that. What it does is basically calculates what type of curve adjacent to each other and then tells you what that field radius is. And here it is. Now we're going to start from beginning and we're going to send it over to SolidWorks. Once it's done, I'm just basically modifying some of the fillets. We have a fully editable CAD file from Design X to SolidWorks. It is ready for manufacturing. And thank you very much for joining us today.